Hello everyone, welcome to this course on the Introduction to the Operation Research. In this video, we will look at a very simple example in Excel and how you can use the Excel to solve the optimization problems. In this problem, we will use Excel inbuilt solver, and if that is not sufficient, we will also use the open solver. What we will do is we'll take a very simple case, and then as we move forward we will keep adding more complexities. For example, more cost parameters, more constraints into the model, more variables into the model, so that you guys understand and see how the optimization you can build the optimization model in Excel. So okay, let's get started. What do we have here? The business problem that we have here is there is a manufacturer who produces 4 products item A, B, C and D. It also has 2 manufacturing units at manufacturing location 1 and at location 2, right? So here, now each of these products can be produced at either of these 2 manufacturing locations, and with the product, each of these manufacturing location has the minimum capacity, maximum capacity and a variable production cost, which is in dollar per unit. We also have the aggregated demand for these products, which is for, let's say, for the next 1 week in terms of the units. What we want to do is, let's say we want to find out which product should be produced at which manufacturing location and in how much quantity. So let's get started. Now, before I start, you might be aware that in the last video we saw the optimization framework. So what I'll do is I'll just relate to that optimization framework, and we'll build this model considering that optimization framework. So to revisit the optimization framework, you saw that in an optimization framework we have 3 components: the decision variable, the objective and the constraints, right? So what are the objective, what are the decision variable and what are the constraints in our model? Let's look at that. So in this case, the decision variable for us is how much to produce each of the 4 product at 2 manufacturing location. That becomes the decision variable. The objective function becomes the total cost. We want to minimize the total cost. The constraints becomes, we have the minimum capacity, like they have to produce at least this much quantity, and we have the maximum capacity. They cannot produce more than this much quantity, right? Then we also have the demand. We need to fulfill the demand. So these are the 3 constraints, and we have a decision variable, which is how much to produce for each of these products at each of these facilities, and the objective function is to minimize the total cost. So let's get started. Now I have copy pasted the data in a different tab here. So here we have the manufacturing location for each of these products, what's the minimum capacity, what's the maximum capacity and the variable cost. Let's say here becomes the decision variable. So I'll just highlight it with a different color so that it's easy to follow along. Now this becomes the decision variable. Let's say what would be the total production cost. The production cost will be this unit cost multiplied with how much to produce. So this decision variable that we have considered, it will tell us how much to produce this product at manufacturing location 1, B item at manufacturing location 1, and then this row will tell us how much to produce of item A at manufacturing location 2, and similarly for the other products. So let's say what would be the production cost. Here this would be how much to produce multiplied with the variable cost. So this would be the cost to produce. Now what would be the total cost? Total cost would be the sum of these costs, right? Now we also need to satisfy the demand. So this is the demand number that we have got. We need to make sure that the production quantity should be more than the demand. So what's the total production quantity for the item A? That is the item A production quantity plus item A production quantity at the manufacturing location 2. So that becomes the total production quantity for the item A, and this becomes the supply for us. I can drag this formula so that it's applicable for all the items. As you can see, it is for the item D. I could have also used a different Excel formula, which is the sum ifs, but I simply put sum for you to understand is more easily than using a proper Excel formula in this case. So now what we will do is we'll go to the data tab here, and we do not have the Excel solver already configured. So to configure the Excel inbuilt solver, what we will do is we'll go to the files, we'll go to the options, the add-ins, and then here we will add the solver add-ins. Now once you click this check button and click on the OK, and if you come back to the data tab, you will see the solver option here. It's an Excel inbuilt solver. So what we will do is since we have calculated the production cost, total supply, we will build these objective function. This becomes the objective function for us, and I can highlight this with a different color, let's say this, and this becomes the objective function, this is the variable, and we need to also implement the constraint, which I come to shortly. Now let's go to the solver. Now if you look at the solver options here, what we have, the first option that you see, the set objective. This means which cell contain the objective function. This is the cell that has the objective function for us, the K3. Now what we want to do, we want to minimize the total cost. Let me reset everything first. Okay, so the objective function is the K3. We want to minimize the cost, so we select the minimize by changing the variable cells. What this means is that which cells contain the decision variable. So these are the cells that are the decision variable for us, H5 to H12. Now it says subject to the constraints. What it means is that what are the constraints in our model, right? So I'll click on the add. So here you see the cell reference, the greater than less than sign here, and then the right hand side of the constraint. So the first constraint for us is that the total supply should be greater than equals to the demand. I'll click on the add, and I can add as a next constraint as well. The second constraint for us is that the total production quantity for each product at each manufacturing location should be less than equals to the maximum capacity. So this is the maximum. So you have seen H5 to H12 is less than equals to F5 to F12, which is the maximum capacity. I'll click on the add. Now the next constraint for us is the total production quantity for each product at each manufacturing location should be greater than the minimum capacity. So I'll select the production quantity should be greater than equals to the minimum production capacity. I'll click on the add because we have added all the constraints. As you can see, we have three constraints here. This one is the demand supply constraint, this is the max capacity constraint, and this is the minimum capacity constraint. So here if you come to the solving method, you see the GRG nonlinear, simplex, evolutionary. Since this is a linear programming problem, we will select the simplex LP and we will click on the solve. So once it solves the model, you see it says the solver has found a solution. All constraints and optimality conditions are satisfied. So we'll click on the OK button. Now you see it found that the total objective or the total production cost to fulfill the demand is almost more than 30K, and this is the total recommended production quantity that we should be producing for each of these items at the two manufacturing location. And you can see here it has satisfied all the demand, and if you notice here it's producing more than the demand for the item B here. Why is it producing more than? Because if you look at the item B here, 150, the minimum capacity here, this line and this line. So what we said, we need to produce at least the minimum capacity. So it have to produce at least 240 at the manufacturing unit 1 and 150 at the manufacturing unit 2. So that becomes the 390, and that's why it's producing 390. So the 300 will go to fulfill the demand and 90 would be considered in the inventory. For the remaining, if you look at the item 1, you see for item 1 at manufacturing unit 1, the unit cost is 13 rupees, but at the manufacturing unit 2, it's also the 13 units. So it could have produced anywhere, right? So won't make any difference. If you look at the item C, the cost is 17 rupees and here it's 19 rupees. So it should be consuming all of the capacity. So it has the, so it's what it is doing is that it's producing 180, which is what's the minimum capacity here at the manufacturing unit 2, and it's producing, since here the minimum capacity is 40 only and the cost is lower than the 19 which is at the manufacturing unit 2, it's producing more than the 40 which is the 80 unit to fulfill the demand. So it has chosen the unit which has the least cost. Here it produced 180 because the minimum capacity is 180, so it need to satisfy that constraint. So that was a simple optimization problem. Considering just the demand and supply, considering simple constraints of the minimum capacity, the maximum capacity. You might see that if you, so let me change some data. For example, let's say, I have put in data here to make sure that the model is feasible, but there might be the cases where your maximum capacity is not sufficient to fulfill all the demand. So let's change this. Let's say here we have 120 plus minimum capacity plus 20 is the maximum capacity. Now, if you go back to the data, resolve the model, click on the solve, you see it says the solver could not find a feasible solution. What it means is that given the constraints, the variables, it does not have a feasible solution. Why? Because if you notice it here, the total demand for product is 500. So I'll just clear out some of these color options. Apologize. Okay. No fill. Here, no fill. Okay. So if you look at this material A, the total demand is 500. But if you look at the maximum capacity, here it's 140 and here it's 260, which means the total capacity at both the unit for item A is only 400, but the demand is 500. And what we said is that the total supply should be greater than or equals to the demand. So the total maximum supply that we can supply is only the 400, but the demand is 500, so the model is infeasible. Right? What we need to do in these kind of scenario and how we can solve these kind of scenario, we will talk more about this in the next video. Thank you.